Hello everyone. I hope everyone is safe and healthy. So this video is about quadratic equations. I hope you have already gone through the blog. So let's talk a little bit in detail about what a quadratic equation is, and we'll also be doing a couple of examples to see how to apply the formulas and to learn a little bit extra about what is already there in the blog. So the general format of how the quadratic equation looks like is of the form ax square plus bx plus c, where we have mentioned that a is not equal to 0. Now the question is, what is quad? So quad is squared. So clearly we can see that we have an x squared term over here. So that's why it is quadratic. Uh, a, B, and C are constants, but A cannot be 0 because if A is 0, then if we plug in A as 0, so it is 0 times x square plus bx plus c, and 0 times x square is just 0. So it turns into bx plus c, which is a linear equation, not a quadratic equation. So that is the reason why we put a condition that A cannot be 0 for that equation to hold as quadratic equation. Uh, this is an expression right now. It's not an equation because equation is only when we equate it to 0. So a polynomial of second degree, which is ax square plus bx plus c, when equated to 0, this equation gives us quadratic equation. And definitely, if it is equated to 0, it will have some values of x which are known as the solution of it. So those values of x, when solved for it, are called either roots or solutions or x-intercepts uh, of this particular equation. Now the question is how to find those values of x. So just like we talked in the blog, we have a nice and cozy formula for it, which is called quadratic formula. So let's talk about that. We have quadratic formula. So the quadratic formula says that the value or the values of x for any quadratic equation is given by minus b plus minus the square root of b square minus 4ac over 2a. Now, what is the value of A, what is the value of B, and what is the value of C? So that entirely depends on what the equation is. So the equation is ax square plus bx plus c is equal to 0. So that's where the A, B, and C comes in. And what does this plus and minus denote? We have a plus and minus sign over here. What does that denote? So plus and minus denotes that there are actually two solutions, and it's pretty much evident that why do we have two solutions, because this equation is of second degree, and when a second degree equation when a second degree expression is equated to 0, it will have two solutions. So there is a general rule that, let's say we have a polynomial of nth degree, so we have ax raised to the power n plus bx raised to the power n minus 1, and so on, and we have this expression equated to 0. So how many values of x does this have? It will have n values of x, which is called n roots. We are not saying that the n roots would all be real. We are not saying that the n roots would all be imaginary or complex. All we are saying is it will have a total of n roots. So it can have a combination of real and imaginary, or it can have all real, or it can have all imaginary or complex. That depends on how we solve, how the coefficients are, and how we solve the question. But all we are saying is if the degree is n, then the total number of roots would also be n. So likewise, since the degree in the quadratic equation is 2, so the number of roots must also be 2. And hence, we have a plus and minus sign over here. When we take a plus sign, we'll have one value of x. When we take a minus sign, we have another value of x. There is a special name for the expression which is inside the square root. It's denoted by d, and it's called discriminant. It's denoted by d, and that is b square minus 4ac. Why do we need to talk about this separately? Because whether the roots are real or imaginary, or kind of what is the nature of the roots, that entirely depends on this discriminant. So how this changes the nature? Let's talk a little bit about that. So if b square minus 4ac, which is d, so case one is if d is positive. So if d is positive, definitely this square root will exist because square root of a positive number exists, and this will have two distinct roots. That's what we can say. So it will have two distinct, rather we can say two distinct real roots, because the roots would be real because the square root exists. What if d is equal to 0? So if d is equal to 0, this complete expression will be 0, because this is entirely square root of 0 is just 0. So what is the value of x which we are getting? The value of x is just negative b over 2a. It means that although we are saying that it will have a total of two roots, but it turned out only one root. So what does it mean? It means that this root is repeating itself. So it does not have two distinct real roots. It has one real, we will say, repeated root. And the case 3 is when the discriminant is negative. So if the discriminant is negative, it means that the square root thing will not actually exist, because square root of a negative thing is a complex number. So what does that mean? It means it will have two complex or imaginary roots. That's what is the significance of the value of d if it is less than 0. So we understand now that the discriminant plays an important role in determining that what is the nature of the roots of a quadratic equation. Let's talk about a couple of examples now. We have talked about the discriminant, we have talked about the quadratic formula. So let's try to solve for some equations that will give us some confidence. So let's say we have an equation x square plus 5x plus 4 is equal to 0. We have to solve for x using the quadratic formula. So it's always a good idea to first write the values of a, b, and c. So the value of a is 1, the value of b is 5, the value of c is 4. So let's apply the quadratic formula now. That is negative b plus minus square root of b square minus 4ac over 2a. Uh, b is 5, plus and minus square root of, we have 5 square minus 4, 1, 4 over 2 times 1. So this is negative 5 plus minus square root of 5 square is 25, 4 times 4 is 16, and 2 times 1 is 2. So this becomes negative 5 plus minus 25 minus 16 is 9. So we have square root of 9 over 2, and this becomes square root of 9 is just 3. So negative 5 plus minus square root, this will just be 3 over 2. So now we see that there are two roots. The one root when we take positive, and the one root when we take negative. So if we take a positive sign, the root will be negative 5 plus 3 over 2, which is nothing but negative 2 over 2, which is nothing but negative 1. So negative 1 is one root. Another root would be when we take the negative sign. So it's negative 5, negative 3 over 2, which is negative 8 over 2, which is negative 4. So we see that the two roots of this particular quadratic equation are negative 1 and negative 4. Let's talk about another example. We have 2x square plus 7x plus 3 is equal to 0. Let's do the same activity here. Let's locate A, which is 2, B, which is 7, and C, which is 3. Let's apply the formula. So it's negative B plus minus square root of B square minus 4AC over 2A. So this becomes negative 7 plus minus square root of 7 square minus 4, 2, 3 over 2 times 2. So this becomes negative 7 plus minus 7 square is 49, 4 times 2 is 8, and 8 times 3 is 24. Over 2 times 2 is 4. So this further becomes x is equal to negative 7 plus minus. What is 49 minus 24? I think it's 25. So we have 25 over here over 4. Square root of 25 is 5. So it's plus and minus 5 over 4. So likewise, we'll have two solutions. One is when we take the positive sign, so it's negative 7 plus 5 over 4. And when once we take the negative sign, so it's negative 7, negative 5 over 4. It becomes negative 2 over 4, which is nothing but negative 1 over 2. So that is the value of x. And this becomes negative 12 over 4, which is nothing but negative 3, which is another value of x. So these are the two solutions for this particular quadratic equation. Let's take another example. This time we have negative 3x square, negative 4x plus 4 is equal to 0. We locate A, which is negative 3. We locate B, which is negative 4. And we locate C, which is 4. So the values of x, the value of x will be negative b plus minus square root of b square minus 4ac over 2a. So this becomes negative of, now watch for the sign, b is negative. So we have negative of negative 4 plus minus square root of negative 4 square minus 4. A is negative, c is positive, over 2 times a. Again, watch for the sign, a is negative. Negative of negative 4 is 4 plus minus square root of, what is negative 4 square? It's 16 plus 4 times 4 is 16 and 16 times 3 is 48 over, and obviously the sign is positive. Why? Because we have a negative over here and a negative over here as well. Over 2 times negative 3 is negative 6. So this can further be simplified as x is equal to 4 plus minus square root of, this is 40 plus 1 is 50, 58, 59, 60, and this is 64 over negative 6. So the two values of x which we are getting are 4 plus, okay, the square root of 64 is 8. So let's write 8 first. And now we can write the two values of x. The first one is 4 minus 8 over negative 6. And the other one is 4 plus 8 over negative 6. So this becomes negative 4 over negative 6, which is nothing but 2 over 3. This is one of the values of x. And the other values of x would be 12 over negative 6, which is nothing but negative 2. So these are the two values of x, which are the solution for this particular quadratic equation. Let's take another example. We have x square plus 2x plus 2 is equal to 0. Right, so in this case, what we are going to do is we will first write the usual steps, that a is equal to 1, b is equal to 2, and c is also equal to 2. Then we apply the formula that we have the value of x as minus b plus minus square root of b square minus 4ac over 2a. So this becomes negative 2 plus minus square root of 2 square minus 4, 1, 2 over 2 times 1. So this becomes negative 2 plus minus square root of, this becomes 4 minus 8 over 2. And this in turn becomes negative 2 plus minus square root of negative 4 over 2. So that's where we'll stop for the moment and think that square root of negative 4, that does not really exist because that's a complex number. So we can make a note that it does not have any real roots. But if we go ahead and solve for imaginary or complex roots, we can rewrite this as a square root of 4 is 2 and a square root of negative 1 is I over 2. So this can be written as negative 1 plus minus I. So the two solutions for this equation would be, there are no real roots, so that's negative 1 plus I, and another solution will be negative 1 minus I. So these are the two values of x which are complex roots. Take the last example in this particular on this particular formula. So we have x square plus 6x plus 9 is equal to 0. Let's locate the value of a, which is 1, b, which is 6, and c, which is 9. So the value of x would be negative b plus minus. Let's plug in the numbers directly this time. So it's negative 6 plus minus square root of 6 square minus 4, 1, 9 over 2 times 1. So this becomes negative 6 plus minus the square root of 36 minus 36 over 2. And 36 minus 36 is just 0. So it's negative 2 over negative 6 over 2, which is negative 3. So this means that it has a real root but a repeated one, since it just has one value. So negative 3 is the only root which is a repeated root for this particular quadratic equation. All right, let's move ahead and let's talk about the graphical analysis of the quadratic equation. So let's talk about the graphs of quadratic equation. Uh, so for representing the graph, this is the quadratic equation is represented as an equation in terms of y is equal to ax square plus bx plus c. We already talked about that this quadratic equation in terms of graph actually represents a parabola, and a parabola can have two shapes. It can either open up, it can either be of this kind. So these are the coordinate axis, or it can either be of this sort. Now the behavior as in this one is called opening up, because definitely the cup is opening up, and this is called opening down because the cup is opening downwards. How to know whether the quadratic equation, the given quadratic equation when graph will open up or down? That depends on the sign of the leading coefficient, which is a. So the sign of a is positive, it will open up. If the sign of a is negative, it will open down. What if the sign of a is 0? Recall again, a cannot be 0, it's a quadratic equation. So a has to be either positive or negative. So these are the two cases in which the parabola can either open up or open down. Now there is an interesting relation between the x-intercepts and the roots, because if we recall, we talked about this in our earlier slides, where we talked about that the roots of a solution, the roots of a quadratic equation are also called the x-intercept. So what does that mean? It means that the values of the values where the curve intersects the x-axis, as in these values as far as the current graph is concerned, or these values, these are the x-intercepts which are also called the solution of the quadratic equation. So we can relate, and definitely we know that the number of solutions or the nature of the roots depends on the value of d, which is the discriminant. We just talked about this, that if the value of d is positive, it has two distinct roots, real roots. If d is 0, it has one real root, which is repeated. And if d is negative, it has two complex or imaginary roots. So let's relate the graphs along with the sign of a to see that what possible graphs are, uh, how many graphs are possible for a quadratic equation. Let's talk about the case when a is positive. Look carefully that there are three such graphs possible. The first graph is like this, or can be like this. The second graph can be something of this sort. And the third graph can be, let's make some space over here. Let's move it a little bit over to right. Third graph could be like this. Now there is a very important difference in these three graphs, and definitely this is all for a as positive, so all these are opening up, so that case is very clear. Now what is the difference? The difference is uh, this particular graph 1, this particular graph is not intersecting the x-axis anywhere. This particular graph is not intersecting, it's touching the point, touching the x-axis at just one point, let's call it A. And this particular graph is intersecting the x-axis at two distinct points. We just talked that the points where the curve intersects the x-axis, that is called the roots. So we can say that graph 1, since it's not intersecting anywhere, it does not have any real roots. This has just one real root and this has two distinct real roots. How can we relate this with the discriminant? If it has no real roots, it means that discriminant is negative. If it has only one real root which is repeating itself, its discriminant is exactly 0. And the third case is definitely when d is positive, which means that it has two distinct real roots. That's a really important relation between the discriminant sign and how it looks in the graph, and this is really important. Likewise, we are going to draw three graphs when a is negative. So I think you might have already figured it out how the graph would look like. So if a is negative, the first graph would look something like this. The second graph could look, these are the coordinate axes, and it could look something of this sort. And the third graph could definitely look when the curve will intersect the x-axis at two distinct points. It can be like this. We know now, we can easily interpret that for this, it's not intersecting the x-axis anywhere, so it does not have any real roots. It means that d is negative. It is just touching the x-axis at one point, let's say a. So this d is 0. This a should not be confused. Let's mark this as a different alphabet. Otherwise, this should not be confused between the ax square plus bx plus c. These are just the random numbers. So let's call it p. Let's call it p and q. Likewise, we are going to call this p and q as well. So let's say this is the root p, and these are the roots uh, p and q. So these are the two roots. So this is how the graph would look like. And for the last one, we have the discriminant as positive. Why? Because it has two distinct real roots. So it should intersect the x-axis at three different points. So this is the interpretation of the graphs. Now we also talked about vertex. So vertex is an important key point in a parabola. So vertex is the point where it turns, So this is the point where it is turning. This is the point where it is turning. This is the point where it is turning. And clearly we can see that the turning point, and in the other three graphs, this indicated point is the point where it is turning. Clearly, we can see that this turning point is also the value where it is either a minimum, where we can see if a is greater than 0, then this vertex is actually the point where the minimum of this parabola is, where we observe the minimum of this parabola. And if a is negative, then this vertex is the point where we observe the maximum of the parabola. So we can clearly say that in a parabola, the vertex is the point of local extrema, because extrema means local minima or local maxima. Now it depends whether on the sign of A, whether it's local maxima or local minima, but that is for sure that it is either one of them in a quadratic equation. We also have the axis of symmetry. So that's axis of symmetry is the line which is parallel to the y-axis and passing through the vertex. So these are the axis of symmetry. I'm just drawing it for all the three over here. So this is the point about which the graph is mirrored. The graph is symmetric about on either side. So just like the name suggests, this is called axis of symmetry. It means that the axis about which the curve is symmetric. So let's name it axis of symmetry. There is one very nice formula which I have not mentioned in the blog. So that's something as how to find the vertex, if because that's an important key point. So let's say we are given a quadratic equation ax square plus bx plus c, and we are they ask us that what is the vertex of this. So vertex obviously occur in an ordered coordinate ordered pair where it has an x coordinate and it has the y coordinate. So the x coordinate of the vertex is given by negative b over 2a, and the y coordinate of the vertex is given by 4ac minus b square over 4a. So this together, when written in an ordered pair, gives us the value of the vertex, the coordinates of the vertex. And this vertex is definitely either maxima or minima. It depends on what the sign of A is. So if A is positive, it will be minima, and if it A is negative, it has to be maxima. We can do a couple of questions on this. Let's take an example which we took earlier. X square plus 5x plus 4 is equal to 0. And they ask us that find its minimum value. So we know that this is a quadratic equation with A as positive. It means that it is opening up. Opening up means that the vertex will have a minimum value. So what is the x coordinate of the vertex? That will be negative b over 2a. So that is given as negative of 5 over 2 times 1, which is negative 5 over 2. And what is the corresponding y coordinate of the of this vertex? That will be 4ac minus b square over 4a. So this will be 414 minus 5 square over 4 times 1, which is 16 minus 25 over 4, which is nothing but negative 9 over 4. So this is the minimum value ideally, because the y coordinate will actually give the minima or maxima. So this is the minimum value, and this is the value of x where the minimum value occurs, and together the vertex will be represented as negative 5 over 2 and negative 9 over 4. Let's take another example on this. It's negative x square plus 2x minus 2 is equal to 0. So what's the vertex? The x coordinate of the vertex will be negative b over 2a, which is nothing but negative 2 over 2 times negative 1, which is nothing but 1. And the and since the a is negative, it will have a maximum value. So we are talking about the maximum value right now. And what is the maximum value? So the corresponding 4ac minus b square over 4a. So that will be 4ac minus b square over 4 times minus 1, which is 8 minus 4 over negative 4, which is nothing but 4 over negative 4, which is nothing but minus 1. So minus 1 is the maximum value, and the value at which it is maximum, it is x is equal to 1. So as an ordered pair, it is represented as 1 comma minus 1. So this is all